Okay, this is the class session for February 5th. This is the recording right now. It's happening. So, and like I said, there was someone who took a picture of me. So I'll post that up here. You could see right now. There are a couple of exciting ones. There's this one. Really cool. It's me. I'm a king. Okay. And then there's this one. Right here. Yes. That's me. Okay. So, anyways, like the video. Because I like it. First period, they're being ridiculous. So, I prefer they don't do that. But that one, it's okay. As long as you do your work, you can mess around a little bit like that. Alright. So number one, I'm going to, on this video, if you're listening, this is what we did in class. We're covering one problem from each section. There's 5 total problems, 5 total sections. And then each problem will give you an idea of what to do on the next 3 following it. Okay? So number one, everyone's writing number 1 down. It's on the board. Look up here. Okay, so number 1, it says factor out the common factor of each expression. It's really important to always read the directions on the test. So it says factor out the common factor. Common factor means GCF, okay? So we're asking ourselves, what's the GCF? So we have 3 terms here, okay? We might be able to X box, but you see it's n cubed, right? So it's not something we want to do, and then there's no n on the last one. So first thing we want to do is take each term, and we're going to factor the numbers, okay? So 16, I'm noticing there's a common number of 4 across, and 16 I know is 4 times 4. And then we have n cubed. And then the second term we have 4 times 1. And then the third term is 4 also. So clearly we could see there's a 4 in each one. The second term is n squared, and the last term does not have n's. Okay, so now I'm going to ask myself about the numbers first. What number is a factor in all 3 terms? 4, right? Which you're already good at this, I know that. And then what letter is in all 3 terms? None, right? We have n, but it's not in the third term, so it's not a factor, okay? So now we're going to open parentheses, and we're going to ask ourselves, 16n cubed divided by 4 is 4n cubed. Okay? Then we have negative 4n squared divided by 4 is just negative n squared, or negative 1n squared. But we don't have to put the 1 down. Okay? And then negative 4 divided by 4 is negative 1. Then we close parentheses. We can't do anything else, okay? So we box our answer. We couldn't do x box here because it's n cubed here, so, and we can't factor it out, so that's our final answer. That's the factored form. Okay, so continuing on, we're going to keep going to number up to 5 now, so you'll know how to do numbers 1 through 4 now. So number 5, this one is his factor completely. So on this one, I'm going to give you a hint. This one is just X box, but whenever you see just factor completely, you need to have this in mind. And you should memorize this order, okay? Is there a GCF first? Yes or no? Can I do X box? Yes or no? If not, is there a B? Can we do difference of squares? Yes or no? And can I, if not, are there 4 terms? Remember, that would be grouping, right? Factor by grouping, which we're going to do. But sometimes there isn't a hint, so you have to know how to pick what you're going to do. Just like in a video game, you know you have all the options ahead of you to do your moves, right? But you get to pick how you get there, right? If you're maybe playing an opponent in Street Fighter, or maybe you're playing, what's that one with the car? Oh, GTA, Grand Theft Auto, right? How many different ways can you go from point A to point B? You could does it take you there automatically, or can you go explore around? Right, you get to pick, but you have to get to your final answer, okay? Okay, anyways. Eyes up here. Okay, first thing I do is ask myself, is there a GCF? Okay, so on this first term, I could divide by 3. 25, can I divide 25 by 3? Nope. I know 28, I can't divide by 3 either. I could divide by 4, but so there's no GCF here. So now I'm going to identify to see if I could do X box. I know I can't do difference of squares because this middle term is present. It's not 0, okay? So A is equal to 3. B is equal to negative 25. C is equal to 28. Okay, so doing our X box now. Plug in your numbers. We know A goes here and here. A times C is 3 times 28, so if that's difficult, just do a side problem. $84 and adds up to be negative 25. Okay? So, now we figure out we need to have a positive product but a negative, summation. So we're going to take 84 and start with negative 1 times negative 84. Negative 2 times negative 42. Negative 3 doesn't work. Negative 4. Actually, negative 3 does work. Negative 3 and negative 28. Negative 4 times negative, 21. Uh-oh. Okay. Isn't that the sign negative 4 and negative 21 right here? Right? I don't know what's going on here. Pause this. Okay, so since the negative 4 and negative 21 I found add up to negative 25, right? That's what we're looking for. We're going to use these, so negative 4, negative 21, in any order you want. And then we're going to box these, ask ourselves, can I simplify these fractions? 3 over negative 4, I can't. 3 over negative 21, I know 3 goes in each of these, so it's like saying 1 over negative 7, really. Okay? So now we're going to make 2 parentheses for our answer. So we got 3x minus 4 times x, or 1x, minus 7. We're going to box our answer, and we're all done. 3x minus 4 and x minus 7. And I'm going to clean this up a little bit because it's a little messy here. Okay? No plus or minus sign in the middle because it's breaking apart, it's multiplying. All right, any questions on number 5? Okay, so that's how you do 5, 6, 7, and 8, okay? You good? Ready to go? Okay, so keep in mind these 4 questions. GCF, X box, difference of squares, 4 terms. Today I'm giving you the idea of how to do it, but on the test you might not have that idea. Continuing on, we're going to jump down to number 9. So you should be good up until 9. Okay, number 9, again, it says factor completely. It doesn't give us an idea of whether to, it doesn't give us an idea of what we should do or what strategy, but we still need to ask ourselves these 4 questions. Is there a GCF, X box, difference of squares, or are there 4 terms, okay? So on number 9, is there a GCF, okay? Not really, because there's only 1 here, right? 1 times 1 is the greatest GCF that could be here, so we can't break it down anymore. Can I X box? No, because B is equal to what in this example, everyone? 0, right? There is no B, right? We know that A is 49 and C is equal to negative 1. There's no B, so we say it's 0, right? So this is nice because I know 49 is a perfect square and I know 1 is a perfect square, right? You all agree? So all of a sudden now, we're not going to do GCF, we're not going to do X box. We know it's difference of squares, right? So since that's the case, we could just apply the shortcut really quickly. Open up 2 parentheses. Okay. Square root of 49, p squared is 7p, so I'm going to put 7p here and here. Square root of 1 is 1, right? Put a plus sign in the first one, minus sign in the second one, and you're done. Okay? That's it. Now I want to make one note. Some of you get confused on your homework, I noticed. What if the problem originally said 1 minus 49p squared? Do I move the 49 to the front? Yes or no?
No.
No, we do not. Look up here, please. If the problem was like this, you would still do the same thing, except you would ask yourself, what's the square root of 1? 1. So you put 1 first. Square root of 49p squared? 7p. So are these the same answers? Are these the same answers as the first or the original problem? Yes or no?
Yeah.
No.
No. Wait, no.
They are not. The first problem says 7p plus 1. This one says 1 plus 7p, which is the same thing, right? But look at the second one. 7p minus 1. This one is saying 1 minus 7p. Is that the same thing? No, it's totally different, okay? So be careful in what order. You always just keep the first term, bring the first term down first, and then bring the second term down second, okay? So that is the only trick on this one. All right, raise your hand if you need time to write this down. All right, so that should take you up through, let's see, this is 9, 10, 11, and 12. Jump down to 13 now, please. 13, write that one down for me. Continuing on, number 13, it says 6n squared plus 46n minus 72, okay? Again, you should memorize the order, right? I'm going to put this up here again. Checking for GCF first. Now in this problem, this is a combo problem. Numbers 13 through 13, 14, 15, and 16. These are all combo problems. I did that on purpose. I'm telling you right now, but look at the directions. Does it say combo?
No.
Use a combo? Yeah, it doesn't, right? So it just says factor. So I still need to ask myself, is there a GCF? What do you notice about all three numbers up here? They're all what? Odd or even? Even. When numbers are even, they're automatically divisible by 2, right? Does that make sense? Are they all divisible by 2? Yep, they're all even. How about, let's just make sure they could go, or there aren't any other factors that are greater. What about 6? 3 goes into 6. Does 3 go into 46? Nope.
Yeah.
No, it doesn't. 3 times 15 is 45, so we know that doesn't work. 4. Does 4 go into 6? Nope. 5, does that go into 6? No. 6, does that go into 6? Yeah, okay. Does 6 go into 46? No. Okay, so we know the greatest common factor is 2. So we're going to do GCF first. We're going to factor out a 2. Okay, so 6n squared divided by 6, or divided by 2 is 3n squared. 46n divided by 2 is positive 23n. Negative 72 divided by 2 is negative 36. Okay? That's the first step. Right? Still looks like big numbers, but we could do this, okay? So now we have a GCF. Now we're going to figure out if we could do X box. So we have A is equal to 3, B is equal to 23, C is equal to negative 36. Okay? So the first thing I want to do is figure out if we could factor this. So using our X box, we're going to draw an X box now. Putting down our A, which is 3 and 3. 8 times C, 36 times 3. You could do a side problem if you don't know how to do it in your head. Okay. 6 times 3 is 18. 3 times 3 is 9. Plus 1 is 10. So, and we have a positive times a negative, which is negative 108. And it has to add up to positive 23. Okay. So, we need to have a negative product, but a positive sum. Okay. So we're going to focus on bigger positives and smaller negatives, but we're going to do positive times negative, starting with positive 108 times positive, or times negative 1. That doesn't work. Positive, let's see, what's 254? So positive 54 times negative 2. That doesn't work. Positive 36 times negative 3. That doesn't work. positive, let's see, 27 times negative 4. What's positive 27 minus 4? 23, right? This one works, right? Isn't that what we need? 23 right here. So now we're going to go over here 27 and write negative 4. X box and checking to see if our answers are simple. If we could simplify these fractions. 3 goes into 27 and 3 once and 9. Right? And 3 over negative 4 doesn't work. So now watch. I'm going to move the 2 down because that was our original GCF. Can't forget that. Open up 2 sets of parentheses. So we got n squared is the one we're factoring. So we got 1n plus 9. And then we got 3n minus 4. Okay? And we can't factor anything else, so we box our answer. Okay, so this was a combo, right? We did a GCF, and then we did Xbox. Now sometimes you might just do the GCF and you can't Xbox. So you wouldn't put not factorable, you would put 3, or you just keep it as the second step or first step, 2 times this amount, okay? So please write this down. All right, so this should take you up through, this is going to be 13, 14, 15, and 16. Now let's jump down to 17. Okay, so this is what we learned yesterday. It still says factor completely, or each completely. It's the same direction. So I'm not going to give you a hint, right? I'm not going to give you a hint on your work. So you have to ask yourselves these 4 questions. Is there a GCF? Okay, and we should still check for a GCF. 42 is divisible by 2. Okay. 18 is divisible by 2. Is 35 divisible by 2? Nope. No. So is even to a GCF? No. So we know right now that the only numbers that could work are 7 and 5, but 7 doesn't go into 18, right? So 5 doesn't go into 18 or 42. So there's no GCF here, right? They're all kind of different. So the first thing we're going to do is now see if there's going to be, we have 4 terms. We know we don't have an X box because there's 3 terms. Okay, so no GCF, no X box, definitely not difference of squares. We have 4 terms, so we're going to just focus on that. So now we're going to factor each of these out. So 42m cubed is like saying, let's see, we want some numbers that are relevant. So 15 is like saying 5 times 3. 35m is like saying 7 times 5 times m. 18 is like saying 3 times 6 times m squared. Okay? And then 42m cubed is like saying 7 times 6 times m cubed. Okay? So what are the relevant numbers I'm noticing here? The greatest. 7 and 3 or 6 and 5. Right? Because we have 6's here and 5's here. Okay? So at this point you have to pick the greatest common factor. So let's try to factor out the 7's first, okay? And if that doesn't work, we might have to start again. But it should work, okay? So let's take terms numbers 1 and 3 and put them together. So we're going to write 42 m cubed plus 35m. Okay, we're grouping these together, adding a plus sign, and then we have negative 18 m squared minus 15. And we're putting parentheses around here. Okay? So out of the first pair of numbers, we know that 7 goes into both of these, so and m is in both of them, only one time. So I'm going to pull out a 7m. So we know 42m cubed divided by 7m is 6m squared. Okay. 35m divided by 7m is positive 5. Close parentheses. On this next one, look what sign is in front of both of these numbers. What's the sign that's in front of both of them?
Negative.
A negative. So I'm going to take out a negative, and we said it's negative 3, right? Open parentheses. Negative 18m squared divided by negative 3 is positive 6m squared. Negative 15 divided by negative 3 is positive 5. Okay. At this point, did we group correctly? Do we have the same factors? Yeah, we do. So this part's easy. We're going to factor out 6m squared plus 5. So we literally just copy it down again because we're factoring out this GCF. And we're noticing we have 7m minus 3. Box our answer, and we're done. Okay, this is factored by grouping, right? Okay, that's it. Now, sometimes you can factor again. I want to say, let me give you one example here. I just want to show you something. What if our answer was not this, but was actually this? Let's say it was 6m squared. I'm sorry. Actually, just m squared minus 3, or no, sorry, minus 4 times 7m minus 3. Let's say this was our final answer. This is just pretend, okay? This is not what you would do. Okay, but what if it was like this? What are you noticing about one of these terms? Raise your hand what you notice. What do you notice about one of these? M squared and what else? What are you noticing here? Anyone's? What's this m squared minus 4? Isn't this a difference of squares? Right? So couldn't you technically take this first one and break it down to two parentheses again? M, put m, and then 2 and 2. Plus and minus. Would you all agree that this turns into that? Yeah, so then you could still do another step. So sometimes that does happen. I didn't give you that for homework, but be ready for that in the future because you could break it down some more, right? So you see how we have 3 sets of parentheses sometimes? But this wasn't the answer to number 17, by the way. This is not the answer. The answer is right down here, okay? So this is just a what if, okay? All right, and that concludes the lesson here.